I'm Danielle Peterson from Infrastructure News. Today we are talking to Alaster Goyns and Sam Efrat, both board members of the Southern African Society for Trenchless Technologies, or SASTT, and we'll be discussing the use of trenchless techniques and technologies in South Africa. This is CPD On Demand. Now, Alaster, Sam, can you just introduce yourselves, tell us a bit about yourselves?
Well, my first involvement with trenchless technology in the workplace was in 1977. And that was really on large diameter pipes, and it was related to pipe jacking. And when there was a decision to possibly form an organisation, then both Sam and myself were at the first inaugural meeting, and we went out of that meeting having been selected as being board members. So we've had quite a long route together on trenchless technology. At present, I own a small company called Pipeline Installation and Professional Engineering Services, abbreviated to PIPES. And my focus is on buried pipelines and on trenchless rehabilitation and condition assessment.
I've been involved in trenchless technology since 1987 when I presented a discourse for my undergraduate BSc Building course on trenchless technology. I'm currently the managing member of Trenchless Technology CC. I'm a past president of SASTT and currently vice president of SASTT. And SASTT we are actually 25 years old now as a society. Both Alaster and I attended the inaugural meeting of SASTT. So we've come a long way together, and we're quite proud of the achievement of SASTT to get to this milestone.
Okay. Now, Sam, Alaster, perhaps you can tell us a bit about the scope for utilising trenchless methods for construction projects in South Africa.
South Africa has 500,000 kilometres of water and sewer pipes. By now, 40% of those pipes need to be replaced. Most of it is in urban areas. By using trenchless technology, you're able to go under the ground, through the ground, making use of the existing pipe as an asset. So you don't need to disturb the driveways of the roads, create open holes in urban areas that become dangerous. There's also potential cost savings. So the scope for use in South Africa is such that when we get going with our replacement of water and sanitation piping, we stand to save possibly 200 billion rand using trenchless technology.
From a technical point of view, if you're considering it, it's not actually the pipelines that are the asset. It's the hole through the ground that's an asset. So the pipeline inside that hole is making sure that the delivery of water, the transport of water or the other fluid is actually done effectively and efficiently, because that lining makes sure that hole remains structurally sound, that it remains watertight, that it keeps on functioning and you don't have infiltration or exfiltration of water into the pipeline.
What we're saying is that on a long-term basis, if you look after the asset, which is the hole in the ground, you can have an infinite lifespan with that pipe by relining it or reusing it, provided you catch it in time so that it doesn't go past a certain point of repair.
And in terms of, you say, 40% needs to be replaced. How quickly is that happening? What is the uptake there?
At the moment, if we just do some mathematics, we put some sums and numbers to it. If the asset lasts you 50 years, so let's say your water pipe is installed 50 years ago, after 50 years it needs to be replaced. It means that every year you should be putting 2% of the original capital cost into replacing the asset. In order, after 50 years of 2%, you've got 100% available to replace the asset. I would say that in South Africa we're doing less than 1/4 of 1%. replacement of our buried assets. So at the moment we're falling far behind.
And then this has to be looked at in terms of the urbanisation, which in this country is about double the population growth, or pretty close to double that.
Yes.
And once an area is established and you start digging trenches, you cause a whole lot of disruption, both socially, environmentally, commercially. So by using that existing hole through the soil and either just rehabilitating it or even upsizing it, that you are improving the way in which that service is being provided. And in addition to that, most of the techniques are being used. It's not a matter of the original concept of 40 or 50 years. If you're rehabilitating something, that you're usually going to be rehabilitating it so it lasts for about 100 years. And that means there's a chance of catching up with the backlog of putting in new services where they need it.
Yes. Maybe then, just in terms of rehabilitation, you can run us through some of the methods that are available to rehabilitate water pipes, sewer pipes in South Africa.
You're probably looking at three categories of trenchless work. You're looking at just pure rehabilitation where there's an existing pipe and you're improving its performance. You then have where in many cases with urbanisation, it's not adequate just to rehabilitate that facility because you've got a much denser population, you need to upsize it. So in addition to rehabilitating and reinstating that service, you can provide the service for more people. So if you upsize, like you're doing with pipe bursting, and you could make that pipe twice the size it was, then you're going to get about 6 times the capacity. And then the third aspect is where there are no services and it's inaccessible, then you can use techniques like pipe jacking or directional drilling or micro-tunneling to put new services in. And those three aspects of trenchless technology, the work, are then supported by things like CCTV, laser profiling and that, so you can assess the condition of old sewers or you can assess the condition of the soil below the surface.
But just to broadly categorise the rehabilitation is either rehabilitation of an existing asset, which is the hole, by relining, so it's non-destruct, or replacement. Replacement would be using the asset, the hole, but expanding it or putting a tool down so that you pipe burst it and pull a new pipe into its place.
And can you expand a bit more on the technologies available to perform those functions?
Sure. For relining, which would be non-destructive reuse of the pipe, you have methods called such as cured in-place piping, commonly known as CRPP, a polyester felt sock is let's say resin is introduced into a polyester sock. It's pulled through the whole pipe. It's blown up in place either by compressed air or water pressure, and then it's cured by thermal induction through either water or through UV lights. It's very broadly used. It has lots of uses. It can be used from very small pipes up to pipes of 2 or 3 meters. There's several contractors in South Africa that offer that. It is one technology available out of a toolbox of other technologies. Other technologies could involve spiral wound piping that is inserted through a manhole or a chamber. Inside of a chamber you would have a winding machine that winds the pipe, creates the pipe inside the other pipe. From point to point, once it's in place, it can be expanded, so it can be a close fit. You have also lots of polyethylene solutions which involve reshaping the existing polyethylene pipe, either by putting it through a reduction die to make it smaller and then pulled into place. The tension during pulling keeps its diameter smaller. Once you release the tension, it expands. You can roll the pipe through rollers that also make it smaller. So it's perhaps a more advanced process of die reduction. Or you can take that pipe and fold it into a C shape so that it's more flexible and put it in place and then expand it in place. There are also spray epoxy linings, polyurea, that would enable you to do water pipes non-destructively from the inside. On the replacement side, pipe cracking is the most common methodology. You either put a hammer down the pipe where it breaks out the old pipe, or you use hydraulic pulling power with rods that fit into each other to pull a head through the old pipe and break it open. And today, people are also using directional drilling equipment to ream out the old pipe.
Okay.
All of those reaming techniques or pipe bursting pull in polyethylene piping. But the advantage of the replacement by pipe bursting or pipe reaming is that you can take a pipe that has a certain capacity and size and you can increase it. So, as Alaster was saying, in urban areas where we have densified and you need bigger capacity, there is a solution, a trenchless solution to be used. And in fact, the replacement technologies are very well suited to South Africa because we're using locally produced piping. It is labour intensive, and it's quite a lot cheaper than the relining technologies.
Okay.
So the relining technologies are well suited to complete no-dig in areas where you don't want to excavate at all. The pipe bursting type technologies are suited to urban areas where you don't mind excavating your lateral pits and launch and receiving pits, so there is some excavation, but it's trenchless. It's less trenching, but it's not a complete no-dig solution.
Okay, and so that's covered sort of rehabilitation. In terms of installing new pipelines from scratch.
Maybe let's elaborate a little bit on that about the rehabilitation.
Okay.
With your lining systems per se, what you're going to do is, at the best, you will get the capacity you already had.
Although, because of the smoother walls of the lining material, there's an enhancement factor, so you in fact get better flow through your liner, which has a slightly smaller diameter, but a higher flow coefficient.
Yes.
So you'll get better volume.
Okay.
So you have a slight, with curd in place, you have a slight improvement, maybe 10% on what the original capacity was. On the other techniques, you might get the same capacity, and if you're just going to look at pure slip lining, then the capacity will be less. But all of those, what they're doing is they're reinstating the structural aspects, they're reinstating the leak-proof aspects, they're reinstating the corrosion problems. So there are not corrosion problems anymore. But they do not address the issue of densification, and that's where the online replacement, like pipe bursting, has the great advantage, or pipe reaming, is that you are providing those functions that you do with relining, but you're also upsiding, so you're improving the capacity.
Yes. So it really depends on what the needs are at that point in time. Okay, great. And then back to my previous question of when installing new pipelines, what are the technologies available in that case?
And I think the one big thing about installing new pipes, if you consider a large diameter pipe, say a meter diameter sewer that has to be installed in a residential area and it's 8 meters down, you're going to be excavating a hole which might have to be shored, which is expensive, or if it's open trench, you're probably going to be removing something like, what did we say, 100 cubic meters per meter run. And that material has to be stored somewhere, And where do you store it in a built-up area? You've actually got to transport it somewhere, store it off-site. Whereas if you went trenchless for that, essentially what you're doing is removing the volume of material that you have to put the pipe in. So you'll be removing maybe 1 cubic meter per meter run as against 100 cubic meters per meter run. So you've got 1/10 of the spoil you need, 1/100th of the spoil that you need to use.
So for large diameter pipes, urban areas with depth, it's expensive to use open cut and also impractical. The techniques available to us to do trenchless, the oldest technique, pipe jacking, been around in South Africa for
1960s.
So 57 years.
Yeah.
You know, horizontal directional drilling has been around about 20 years in South Africa. It's so efficient in comparison to pipe jacking. Pipe jacking is you need to get a man inside your pipe. So it has to be a man entry size, generally 840 ID, the smallest size that you should be jacking. Anything smaller previously was being done by auger boring, pipe ramming, let's call them less sophisticated trenchless techniques. When directional drilling came into being, it offered the ability to steer your pipe through a range of different soil conditions. It can be soft, it can be intermediate, and it can be rock. But not mixed material, and boulder material is not good with directional drilling because the directional drilling rods tend to get caught in between the boulders. But it is able to be used in the widest range of soil conditions extremely efficiently. Today there must be 150 directional drills in the country. They're doing sizes for fibre, from maybe 10 to 110 millimeter. For sewer and water from for lead connections for houses, 15 millimeters, 20 millimeters polyethylene. And for water and sewer services from say 50 to probably about 800 is the range, although there are machines in the country that can do up to 1200 diameter. The machines that can do lengths of probably 3 kilometers at a time. It's become the most widely used trenchless tool in the country.
Okay. And you have touched on the fact that, say for in an urban area, if you were digging very deep underground to lay a pipe, it's more cost effective to use trenchless methods. So can we talk a bit about the cost weighing up against digging a trench versus using a trenchless method in any case, whether it's rehabilitation or laying a new pipe?
Let's say you have a water pipe replacement project. It involves your existing pipes, which could be 50 millimeter, 75, 110, 150. Material, generally asbestos cement, although it could also be PVC, or it could be mild steel galvanized with collars. On the sidewalks or in the road, the main pipe is lying. You come along, you dig all your house connections, your laterals, you dig your launch and receiving pits. It's probably 15% of the excavation that you need compared to open cut. You install your tooling in a launch pit. The launch pit can be 2 meters long and by a meter wide. These pipes are generally about a meter deep. You can pipe burst block by block. Generally the blocks can be 40 meters to 120 meters long. The tooling that you use can accommodate that. You would set up on day 1. On day 2 you would crack. You would put a bypass in place as your preparation works prior. You could probably do every second day pipe bursting. Okay. Your lead connections across the road, the pits are small, it's on the pavement, you have a limited amount of space. Traditionally, the use of little molding machines, 45 diameter hammers that are able to be launched from the pit, your lead connection pit from the one side of the road to the other. In soft displaceable soils, it works very well. More sophisticated equipment is needed when it's harder, intermediate, mixed. Directional drilling, pit-mounted machines, they are more expensive. That technology is yet to come to South Africa, but it is available. But a lot of people are doing mowing across the road. If we look at the costs, one mould crossing across the road is being sold for about 300 Rand a metre. Okay? The cost of excavating, replacing the roadway for that lead connection, probably 1,000 Rand a metre. So you have a vast saving to do all your lead connections, regardless of whether you're doing your main part by open cut or trenchless. The lead connections, there is a huge cost saving. You know, we probably 30 to 40% of the cost of open cut. When it comes to the pipe bursting, we look at, for R1 million on let's say a 110 pipe, we could do 1.3 kilometers. Open cut, and this is an urban area, just to describe, it's not fully tarred, it's grassed, it has gardens on the sidewalk, but every driveway has paving or is tarred. So the condition is, for open cut, you could excavate the grassed areas, the gardened areas, you know, the flower beds, but the driveways you could, but there's always going to be scars, so you would probably still want to bore underneath them. By open cut, you would get, for R1 million, it would cost you 1,000 Rand a metre, and you would get 1 kilometre. And it would employ the same amount of people as it would by doing by trenchless. But the difference is that we will do 1.3 kilometres for R1 million, and open cut will do 1 kilometre, employing 60 people, whether you do it by open cut or trenchless.
Another thing to consider about that is if you were going to do it in open cut, that excavation would probably be used, an excavator would be used for doing it, because it's an urban area. People are going to complain if they've got this trench across their driveway and they can't get in and out.
Yes.
So it's done with excavator. That means that if you're going trenchless, you're not using that excavator on site. You haven't got the diesel fumes on site. So from a pollution point of view, social disruption point of view, you're minimizing that.
Yes.
And how many people, if they've got a lawn between their fence and the street, or they've got a flower bed and that flower bed is destroyed, how long does it take to re-establish it?
People would be very unhappy.
What we're saying is that in the urban areas, the residents and the shop owners are definitely going to go for a trenchless solution because it has several benefits in terms of disruption, noise pollution, environmental footprint is much smaller, your carbon footprint is much smaller, the health and safety aspects are much more controlled and smaller, your cost is better, and speed is generally better. You know, so it would look to be a solution that should be implemented 95% of the time. But there's a misconception about the use of or sustainable job creation.
Yes.
And that misconception is unfortunately the one thing out of perhaps 9 benefits, the one misconception is leading to a political will of using open cut rather than trenchless. But we have the message to put across to government. We're working on it. It is our society, South African Society of Trenchless Technology. It was one of our greatest aims is to create the models that we can present to government so that we can change the way that we are doing this kind of work in South Africa. At the moment, there's a white paper that specifically calls on municipality to use labour-intensive methods for this type of work and other work. But unfortunately, it's interpreted in a way that mechanized and sophisticated types of deployment are going to reduce the labour content. And what we're saying is that let's say where the misconception lies is that if you evaluate only R1 million of open cut against R1 million of pipe bursting, they will say that for 1 kilometre you're only using 44 people, whereas for R1 million of open cut we're using 60 people. And we're saying that actually for R1 million we're doing 1.3 kilometres using 60 people, so the model shouldn't be based on a linear metre per labour basis, it should be based on a rand per labour involved in the process basis. So the discount that we are offering is a cost saving. It doesn't reduce the number of people involved. It actually it allows us to do longer lengths at the same price.
Now, in a manual project, the labour would be to dig the trenches. In a trenchless project, what would they be doing instead?
Okay. If we look at the entire operation, let's say we're back to the water pipe replacement, urban area 1 metre deep on the pavement. The first thing we should do is we need to check wayleaves. This is something common to both open cut and trenchless. Make application to the council, the municipality, for wayleaves to be able for us to excavate wherever we need to. The same with the open cut guys. The deployment of people would be the same. The second thing would be to do an investigation of the services in the ground. We can use ground penetrating radar, which is also a tool in the Trenchless technologist's toolbox. We can also make use of radio detection. Ground penetrating radar would give you a picture of the underground, show you the existing services, not used nearly enough by contractors, both open cut and trenchless, to avoid damaging services. The radio detection would pick up anything that puts out an electrical signal, as well as metal pipe. Used hand in hand, you should find 98% of all your buried services. Then mark on the surface where the services are, do exploratory excavations to find them. So far, the ground penetrating radio detection, we've employed 4 or 5 people. The exploratory excavations, another 3 or 4 people, so we're really on about 7 or 8 people. Now that we have done the exploratory excavations, we plan around where the house connection pits are to be excavated, as well as where we can do the launch and receiving pits. The launch and receiving pits would be put in positions of either the lateral connections or in positions of crosses, T's, bends, valves, where we would maximize whatever excavation was going to take place, so that we don't have to dig another hole specifically for the launch and receiving pits. These excavations would employ probably between 15 to 18 people. So we're on about, say, 25 people. Those crews now would leapfrog and continue on to block by block or piece by piece of the project. So they would be doing that specific thing over and over and over in order for us to build up momentum and production. We would then come along and remove certain of the plumbing infrastructure, such as the valves, meters, those aspects the council often would require to be returned to them. Fittings like the T's, the bends, etc. So you would employ another, say, 4 or 5 people doing this, so you're on probably about 28, 29 people. Then the trenchless guys would come along. Sorry, I missed the bypass. Before we, or as part and parcel of the work, we put a bypass piping in place to serve as a temporary connection to the consumers. The bypass would probably absorb about 5 people. So we're on about 34 people. Our trenchless guys would then come along, they would set up the rod pullers or the hammers, all the directional drills. Typically a crew's about 4 or 5 people. So we're on about 30, what are we
About 40.
About 40 people. They would then push the rods through from point to point. We would connect the HDP pipe. HDP pipe needs to be welded. The welding crew would also be about 3 or 4 people. Involve also a vehicle, a crane truck to move the pipe around, a welder, assistant welder, assistant. We attach the pipe, now we're on about 43 people. We pull the pipe into position. We now need to remove our equipment and do the connections. So you have a plumbing crew. The plumbing crew would come along and be probably, it depends on the volume of work and how quickly you're moving ahead, because if you have half the volume or you do it at half the pace, we'd like to tie in within a day. You probably have 6 people involved in this. You also have vehicles, drivers. From a support point of view, you need staff to have prior identified all the fittings, ordered the fittings. You need a clerk to provide the fittings off requisition. You need a driver to take the fittings to site. So your plumbing crew, if you add in the additional support staff with clerk and driver, you're probably looking at about 8 people. So we're on about 56 people. Let's say we're on 50 to 55 people. You've done your connections, now you need to bed the pipe in the points where the pipe is exposed. You need to backfill. So the crew that excavated it isn't coming back to backfill, they're on the next section excavating. So you have another, call it 6, 7 people backfilling. So we've got a crew of approximately, this is without the reinstatements. Reinstatements, depending on what they are, because even though we're only doing 15%, we still have to redo the driveways, the tar, the grass. So that would bring us up to about 60 people. So when we look at this operation, there may be 15 guys that are using pick and shovel, plus the 6 guys that are backfilling. It's about 22 guys. But there's still 40 guys that need to be trained up in specific positions with skills. Be it welding, be it plumbing, be it part of the directional drilling, or the pipe bursting crews. They need specific skills. And this is where we really feel that we can benefit the South African industry, is by creating modules for training through SASTT approved training facilities as we move forward. And this is one of the main goals of the South African Society of Trenchless Technology moving forward, is to have a transformation in the impression of our industry from being a non-BEE to being a very BEE supportive industry, creating long-term sustainable employment.
Okay, now having looked at sort of the unskilled and semi-skilled labour, when it comes down to the engineers, are there unique skills that they need to have? How do they go about getting those skills? Are there enough people with those skills?
I think one of the things from a technical point of view that's really been neglected is to actually establish the health of those services before you start deciding, are you going to rehabilitate or replace? So one needs to use things like your CCTV, or what they now call multi-sensor systems, where especially on your larger diameters, you can be sending either a tracked or a float through a system which gives you a picture. It can also do a laser profiling and sonar profiling, so you can get the dimensional properties of the pipe. So, and it's not just the dimensions that you're getting whether that pipe is deformed, whether it's silted, the amount of silt that is accumulated, and by going through that you can ascertain what the health is. Are there isolated problems? Is it a general problem? How severe the problem is? And if you combine that with what fill is over that conduit, then you're able to establish what the remaining life is. So you can go along a particular, say, sewer, and you can assess that, well, this section's only going to last another 5 years, this section will last 10 years, maybe you'll find there's some sections where you can't even get your equipment through. And you know, the effluent is now just seeping into the soil instead of being transported through the system. So that's indicating you possibly got a localized collapse. So it's very important, or it's essential that one actually assesses the condition of that service before you decide what you're going to do about rehabilitation.
Yeah, you know, as part and parcel of the Trenchless offering, assessment of existing piping is one aspect of Trenchless technology, using either CCTV equipment or equipment that puts out a noise signal or electrical signal, you know, and that aspect of it is done by practitioners of Trenchless technology to reach a point of assessment. The engineering community, I think, is pretty well versed in what Trenchless has to offer. They well versed in best practice, best engineering practice. What they would require is that assessment to be done and presented to them to make a final decision on the methodology of replacement of the pipe.
It's really important once you get to the bigger sizes is what are you going to use to rehabilitate it? Are you going to use something like cured in place? But then you need to have a product that, let's say it hasn't deformed excessively or not badly cracked. And there are other, so one needs to be based on that condition assessment, decide what technique is going to be used for rehabilitation. Instead of just writing into a document that this must be cured in place, there should actually be the option that the contractor can come along and say that for this particular project, you would like to offer an alternative of another system because he feels it would be more effective and more cost effective on the project.
Prior to going out to tender, the assessment should be done.
Yes,
Not as part of a project.
it should be a separate issue. So that condition has been assessed firstly, and based on that, then the document can be written and then it can go out to tender.
And is that happening, or is it generally part of?
I think the critical path of doing the assessment before the tender is tending to happen more and more.
Okay.
Historically, I think it was done as part of the tender, but as Trenchless technology has advanced and the methodology of assessment has advanced, it's definitely becoming a prerequisite to the tender to do the assessment.
And another thing which is coming out of doing this assessment, one is actually finding out what mistakes were made in the past.
Learning from them.
And learning from those mistakes, and then that can be fed into the design process to avoid that happening in the future. And that's also one thing that SASTT is endeavouring to do, is feed back the information which has been found to people who are doing design, to authorities who have services, so that they can relook at their standards in the way they're doing things.
Another important aspect is the post-rehabilitation CCTV and assessment to check that the work is actually being done properly. Whether you're doing the work by Trenchless or open cut, the CCTV gives you a high standard of finished product.
And does that happen often, or is that a negative?
I would say on Trenchless projects it does, because generally we have a pre and post CCTV. On open cut, I'm not really sure of the usage.
And you know, obviously you spoke earlier about needing to educate government about, you know, the labour aspect of it, but just in general, in terms of, you know, the methodologies and the advantages of using trenchless methods, is there a need to educate both government and engineers around, you know, using them and why they should do it?
I honestly think that on a municipal level we have buy-in, because it's pretty straightforward, the advantages, and best practice prevails in the minds of the municipal engineers who are having to operate and maintain those utilities. Government is a difficult level because historically in South Africa, let's say, it's polarized. We have best practice and the entire as-built and engineering community sitting on the one side, and we have unfortunately government on the other side. And we had Civolution Conference come together to try and get at least the as-built environment and engineers to have one common voice that we can talk to government and then once we had consolidated our position, to talk to government so we have a united voice, and then try and get government and best practice and engineering on a common field. Okay. Unfortunately, the as-built environment couldn't quite come together with one voice, and that voice has not quite got to government to be able to sit and really look at what are the aspects that would benefit South Africa moving forward. So there is a divide. We hope to be able to bridge that divide by providing the right information to government so they can be supportive of the technology and see that it is a technology that can benefit South Africa from a labour perspective, an upliftment of all people, regardless of race, and save South Africa a lot of money. But we have a lot of work to do because it is not an easy job to do, but we are focused on doing it and committed over time to be able to get that message across.
And I think we did touch on it a little bit in the beginning, but the uptake of using these trenchless methods, how is that going in South Africa? Is it progressing well? Is it slow?
Trenchless technology really got going in South Africa in about 1985. Johannesburg, at that time, Johannesburg started to do quite a lot of the replacement of steel piping by slip lining. And it's pretty easy to slip line a pipe in comparison to pipe bursting it, because slip lining would involve cleaning the pipe, pulling a proving piece of smaller diameter through, and then pulling your pipe through. The disadvantage is that it has a smaller diameter because you not only need a gap to get your pipe in, and then the pipe wall, so the final ID is quite a lot smaller than the existing pipe. But the uptake, because of the ease of doing it, was fantastic for a couple of years. While that happened, the mowing machines were going across the roads, and the trenchless uptake in Johannesburg was phenomenal. There were several contractors that had changed their focus from open cut to trenchless. They're doing exceptionally well. Technology was just flowing into the country. At around that time, Cape Town also got going with pipe bursting on sewer pipes. Cape Town, high groundwater, dune sand, anything of depth is going to cost you a lot of money by open cut. So there was a very good uptake for probably like 10 years in the country. Pretoria as well got going in at that time. Over a 17-year period, Pretoria CCTV'd 4,400 kilometers of sewer pipe, and they replaced probably 500 kilometers by trenchless technology. Unfortunately for trenchless technology, being buried underground, it's not something that most people look at and consider to be an asset that can depreciate, because it's out of sight, out of mind. And the priorities in South Africa shifted from maintenance of those services to installing water and sanitation for communities that previously didn't have that. And let's say fantastic what we have done in order to increase our water and sanitation to, water, availability of water. I think the percent is in South Africa.
It's over 90% in Gauteng.
Yes, and we have done fantastic work in South Africa to do that, but consequently the money didn't go into the 2% of replacement of the asset per year, and we've fallen drastically behind. And for the last, probably from 2010 to now, the uptake of trenchless technology has probably halved from 2010 to now. Along with the recession in South Africa, I think that civil engineering is probably suffering. General civil work is probably suffering at the same ratio as Trenchless, but we don't see that huge uptake. Recently, Alastair and myself attended the North American Society for Trenchless Technology conference, which was undertaken in conjunction with the International Society for Trenchless Technology. There were 2,300 people that came through to the exhibition. There were 195 exhibitors. There were approximately 170 papers presented. The North American uptake is absolutely phenomenal. They have 8 different chapters in the United States for trenchless technology. You know, so we have the Southern African Society.
Yes.
The North American Society is already divided into 8 chapters. They have 23 university chapters.
Oh, wow.
Their message is far and wide, and engineering and government are now on the same page. It looks to be a $1 trillion industry for rehabilitation of the water and sanitation in the United States. Australia is no different. 2015 No Dig Down Under was at the Gold Coast. They probably had 150 exhibitors. They had 500 delegates attend the lectures. The uptake in Australia is fantastic. They do not want to excavate at all. They're using the more sophisticated lining techniques. They're staying away from the manual techniques. And throughout the country, trenchless technology is replacing all the water and sewer pipes. You know, it's political will and best practice of in the same direction. And that's what we need to achieve in South Africa. We need to find a common goal to replace our water and sewer pipes, which is a critical critical to the survival and good health of our entire nation. And however we do it, whatever the split between trenchless and open cut, we all have to come to a common goal and the best practice to be able to do that. Because if we don't, South Africa as a nation is going to suffer, and we really need to pull together and push in the same direction on this issue.
Okay, now you are both members of the Southern African Society for Trenchless
Yes.
Technologies. So maybe you can then expand a bit on the role that the association plays and how you are trying to promote the use of trenchless technology in South Africa.
Well, one thing that's happening is international no-dig conferences in South Africa next year in Cape Town in October.
Correct. 8th and to the 9th of October at Cape Town International Convention Centre.
And in preparation for that, we are endeavouring to run a short course or seminar at each one of the metros in the country. So we will be starting to have roadshows going around the country to metros. I've also been taking opportunities wherever there are to speak at other events on infrastructure and give a talk on trenchless technology, just to create an awareness and expand the awareness and let people are aware of it, but they're not quite sure just to what extent it can be used.
I think we, between now and let's say October next year, we're probably going to be involved in 20 different exhibitions and conferences where we will present a paper. We have a good relationship with 3S Media in both EMISA and Water and Sanitation, whereby twice yearly in both magazines we have the Trenchless News. Generally we have an AGM once a year. Our members come along, we disseminate information to various bodies. We are associated with SASTT.
That's the Plastic Pipe Association.
Yes.
No, that's basically the one organisation which we've had
Yes,
quite a lot
but
of.
we're associated with a few other
Yes.
organisations that we are associated members. Through the other organisations, we also put our message across as we do their message. We work together with them. Look, we have to understand that we're a small organisation in terms of membership. We have about 70 members, of which Probably 60 are corporate and 10 are individual. We have a board consisting of 7 members plus, at this point, 2 co-opted members. We work together. No one is employed except the secretary. We have a secretary employed part-time. Everyone else is voluntary. So we as an organization, it's a labor of love that we come together to put our technology forward to the industry. I must give a credit to Joop van Vommelen, who in 1992 called the inaugural meeting of SASTT, South African Society of Trenchless Technology. Alastair and myself were both at the meeting, as were probably a dozen or so other budding contractors and engineers. And we formed the society, and it grew from its budding conception to the point that it is today. Unfortunately, Joop passed away 2 years ago, which was a big blow for the society, because Joop was the honorary director, and he took care of all the administration of the society. And in a way, I suppose we took it for granted that Joop would always be there. And he worked tirelessly full-time on SASTT and attending the international conferences. Since Joop passed away, I must say that we have consolidated, I think both the members and the board has come together to really push to put our message across to the industry. And we're doing a lot of work on various aspects to be able to do this. Our strategy moving forward is to have monthly press releases, putting our Trenchless methodology and strategy across our message to industry and government, as well as a snippet of information, making use again of our friends in the industry and our associated societies, the seminars, papers, and preparation of papers, presenters from the seminars we do now to be able to put them forward for 2018, because we have a lot of work to do as well to prepare for the international conference. While the International Society of Trenchless Technology will bring the world here to see the exhibit and attend the conference, we have to get our local guys to support and buy into the technology. So it's quite a mission and goal for us to have a successful 2018. It's the first time that it will happen on the African continent, and it's a big one. When I say it's a big one, on an international basis, other countries compete for it. In 2015, we were successful in our bid and presentation to the SASTT against Helsinki and Bucharest. Consequently, since then, the 2019 International Society will be held in Venice by the Italian Society, but Bucharest and Helsinki are still fighting for 2020. And you have a lot of competition. In fact, Tokyo was competing for 2017 as well as London, but they both pulled out of the race for 2020. So, on an international basis, this is a big one. You don't get bigger than the international conference for us. So we're extremely excited about it, but we do have a lot of work, and we're hoping that our efforts, including interviews like this, will spread the word and create more local involvement in the conference.
Well, Sam, Alaster, thank you so much for your time and sharing with us all your insights and expertise. This has been CPD On Demand.